All right. The good news is, in practice, you don't plot face portraits by hand. You actually do it with the help of a computer. And what I want to show you today is this cool pplane app that does precisely that. It sort of rhymes. And for this, let's plot the face portrait of x prime equals ax, where a is 1, 3, 3, 1. But this time with the help of a computer. But I do want to mention, this is an ODE that we dealt with before, and we found this beautiful face portrait here, where we had those two axes, 1, 1, and 1 minus 1, and one axis goes towards the origin, the other one away from the origin, and our goal is to recreate this. And so what you do here, you go to your favorite web browser, and you search for pplane app. And there should be one that comes from the University of Arkansas. You do this. And this gives you your equations. So the first thing is like x1 prime. The second thing is like x2 prime. So here our system was, I think, 1, 3, 3, 1. So what you do, on the first line, you do 1 times x plus 3 times y. So that's your 1, 3. And on the second line, you do 3 times x plus 1 times y. So it's kind of 1, 3, 3, 1. And of course, don't forget about the multiplications. Those are very important. And then all you do is you graph the face plane. So you do this, and automatically it gives you everything. How cool is that? And not only that, you can even plot some sample solutions, just like the D-Field app, simply by just clicking on several solutions. So I might ask you to do that on a programming assignment, and I might tell you plot 3 solutions per region. This is what I mean, because here we have 3 regions, and you just plot a couple of the solutions. And of course, we can do it for different differential equations. So for instance, let's try to do it as for the following. Let me try to annotate. How about x prime equals ax, where a is 5 minus 2, and then minus 1, 4. Same thing here. So it's just 5 times x minus 2 times y, and then minus 1 times x plus 4 times y. Let's plot this. Oh, it's so pretty. And then what we get is, in this case, if I'm not mistaken, yeah, they're all positive eigenvalues, so they all move away. And it looks really cool like that. And of course, we can do complex things. So maybe, let me annotate correctly. Here, clear. Let's try to do x prime equals ax, where a is this time 1, 5 minus 2, 3. In that case, again, you just need to change the numbers. So 1 times x plus 5 times y, and then minus 2 times x plus 3 times y. Let's do that. And whoa, you get something so spirally. How cute is that? And last case I wanted to consider is 0 eigenvalues, because we haven't really covered this. Let's see. So let's try to do x prime equals ax, where a is 4 minus 4, and then 6 minus 6. And well, in that case, once again, you just change the numbers, 4 times x minus 4 times y, and then 6 times x minus 6 times y. Again, don't forget about the parentheses. And the picture is really cool because it turns out here, the solutions, they're parallel lines, except notice the change of orientation here. Because on the left-hand side, the lines go southwest. On the right-hand side, the lines go southeast. And if I'm not mistaken, I think in the middle we have just points. And in the next video, I'll show you even cooler face portraits.